Today I will be covering what we went over last week, so a brief review followed by how to use the library dplyr and what libraries are more in depth. So let's just quickly review our RStudio cloud. Well, this is a cloud, but this is what RStudio looks like in general. When you launch it, a lot of times you can only see the console tab. Just remember to click here, this button, if you want to see the code. So top left is where we write code. Bottom left is where that code prints out. Top right is where our saved data, variables, and data frames go. And the bottom right is where our files are. So today we are going to be working from this file. And let's just briefly cover what we did last week. So we just launched RStudio. We can run code by clicking the run button after we've highlighted, or we can use Command Shift and it will run. We can write comments with the hashtag, save comments, and we can lastly save data by writing the name of the data that we want to save. So save data name. This can be anything again. Whenever you save a variable or a data frame, you can name it whatever you want. Just don't have a space. It needs to be connected. And then we can save a string, for example. And then it will save up in the top right. And we can also do that with data frames by reading in a CSV file. Now, I don't actually have a CSV file uploaded for this example, but just to cover what we did last week, if the file is in the same folder as this code, is this the same code? And then all you need to do is write the name of the file, followed by .csv. If it's in a subfolder, name of folder, and then slash. Okay, and then once you save that, it will show up here. But for today's example, I am just using data downloaded directly from GitHub. So this is from one of my other GitHub pages that has a CSV file. I just save the URL so that I actually save as a string, and then I will import it with the read.csv, and then it will show that we have successfully uploaded that data frame. Now let's just briefly cover what we did last week. We learned the head function, which shows us the first couple rows. You can tweak this by typing in a different number. So if it's 5, it will show the first 5 rows. The names function with our data frame in the middle will show us the column names of our data. The summary with our data frame name in the middle will show us the summary statistics for each column, as you can see there. And our mean function, which you cannot use on the whole entire data frame. You need to select a column. And we can select the column by, let's move down here a little bit. We can select the column, as I showed last week, by typing in a $sign followed by the column name. Again, this little sweep button can clear out the console and make it seem a little bit easier to read. This sweep button up here will clear out all your variables if you want to clear them out. And when we select the column, we can see all of the data. But when we want to show the mean or the median or something, we can just put that column data in the mean function, and it will show us the mean or standard deviation or whatever it is that we wanted to see. So anyways, that was a quick review of what we covered last week. I want to jump into what we will cover this week. This is a really important point here. So when we are installing a library, a lot of people have a lot of difficulties. And actually, I should mention what a library is to begin with. So a library is essentially a way to access functions that are not built into R initially. So let's just look back up to this example that I showed you. Print is a function, read CSV is a function, head is a function, names is a function, so on and so forth. But these are all functions that are actually built into R itself. So a lot of times, though, there's functions that aren't built into R. And so when we want to access those functions, we will upload a library. And those libraries will allow us a variety of functions. And this could range from maps to graphs to machine learning algorithms, you name it. The one that I want to show you today is a library called dplyr. So the first step to installing a library is to type in install.packages and then the name of the library in quotes. So I actually already installed it, so that's why it's doing that. But if I restarted it, if I restarted R, you would have to download the package again, and so that's what I'm doing here. So install.packages, and it takes usually a few minutes to load. And after it has been installed, so it's actually still installing, you can see this little stop sign means it's going, it means it's thinking. And so after you see the downloaded source packages are in yada yada, if you see this, it downloaded, and now we can use step 2, which is to run library and then the name of that package that you installed. Now there's some warning messages here, but it did successfully install, and the way we can check that is if we run that again, that library dplyr, you'll notice that it's blue, which means that it's working. So that this means it's working when it's in blue. Now, a lot of people, again, just make mistakes by not installing the package and trying to run this right away and then seeing an error. And then people get a little bit confused, but just make sure that you've installed it. Now, someone asked me today in the TA session, do I need to do this every time? And the answer to that actually is no. You don't need to install the packages every single time. If you saved this workspace, you don't need to install it again. However, if you open a new workspace in R, if you were to do a new project, you would have to, of course, install this again and go through that process. But if I were to shut this down and come back to it, I would not have to install it again. Okay, so what does this exactly allow us to do? So in dplyr, there's a variety of functions, and these functions are, you can use them by using this pipe operator that I'm showing here. On a Mac, the shortcut for this is Command-Shift-M, and on a PC, it's Control-Shift-M. And what that does is it allows you to run a function by typing in the name of the data and then followed by the operator and then the function. So I can contrast this with what I showed you last week, which is the head function, and then inside I wrote the data, and then I wrote the number of rows. Whereas if we use the pipe operator, we can just simply write the function, and we can use it to access this data that we're specifying. So these will actually give the same answer. Now I'll show you why that's convenient below. So the first function we are going to look at in dplyr is the select function. Now the select function allows you to select specific columns, and it's pretty self-explanatory, I think. Let's just take a look first at our data. So our data you can look at by clicking this little button here at the top right, and it will show you all of the data, all the rows and all the columns. So what if I wanted to just select one row or one column or two columns? Let's just do one to begin with. I would type in the name of the data frame followed by the pipe operator and then the select function and then vote, because that's the name of our column. And it would print off an extremely long list of that column. Now if we wanted to just see the first 5 rows of that vote column, all we would do is attach on another pipe operator and the head function, and it would show us the first 5. And I use this a lot in these examples here, just to make it a little bit easier to read. Now, I'm actually going to clear this data out here just to show you something. I need to now re-download that data. But what I wanted to show you is that if you noticed here, when I ran this function, it's just printing it out here. But say we wanted to save a new data frame with just some of the columns, not all of the columns in our original data set. What we would do is we would type in exactly what I have here, but what we actually need to do is we need to add a name. Of course, it needs to be spelled together, followed by an equal sign, followed by that same exact code. And what you will notice is that now we have a new data frame, and that new data frame actually just has only 2 columns. Now, I really like to do this, and I think it's what makes it a little bit easier to use than Stata, is because we can just make different copies of the original data set without actually manipulating that original data set. So we can always have the original copy, and we can refer back to it. So if I make major changes, this is actually usually what I do, just as a heads up. So we can also use a little bit more advanced conditions when we want to select columns. Like, for example, we can select columns that start with a certain letter. So in this example, I'm selecting columns that start with the letter V, and as you can see, vote got selected. You can also select columns that end in a certain letter. And so in this example, ION, I'm telling it to look for columns that end in ION, and we get education column. And you can also do this with any letter, and that's the contains function. I'm just kind of cleaning this up here. And that will select any column with a C. And so this will be helpful later on when I show you how to do assignment 1, I think, because there's hundreds and hundreds of columns sometimes in our data, and we want to be able to shrink it down without naming every single one. So that is select. Now we will move on to filter. And filtering is actually selecting rows rather than columns, as I just showed. So when we want to filter by one condition, what we type in is the name of our data frame followed by the pipe operator, and then that filter function. And so in this example, I'm filtering out all the people in our data frame that have an income level above 6. So if you run this, you'll notice that all of these observations are above 6 for income. Play around with this, please. Then you can figure out, I think, a little bit better what it does. If you wanted to use, for example, education, you can. So education over 3, you could show all the observations that have an education over 3. Now, exactly like I showed before, if you wanted to show like highly educated people, so is there people? Nope, there's no one over 4. So education over 3, we can think of that as highly educated people in our sample, and we can actually save that by typing a new name, highly educated equals that exact function. And then we can see that we have a new data frame, and it has a lot fewer observations, obviously, because we filtered out a lot of the different rows, but that will allow us to have a new data frame. We can also filter by multiple conditions by adding an AND symbol. So this will filter by incomes between 6 and 9. And as you can see, income is between 6 and 9 for all these observations. If we want, we can always, of course, as I mentioned earlier, add the head function to just make it a little bit easier to read, but we don't have to. We can also filter by not equals condition, which is the name of the column that we are selecting, and then that we're filtering on, and then not equals is exclamation point equals, and then whatever it is that you don't want it to be equal to. So in this example, I want to show only the people who did not vote, so whose vote is not equal to 1. Now I'm going to move on to arrange. Arrange, I think, is pretty easy to understand. It just sorts the rows by a certain column. So in this example, I'm sorting by age. And what you'll notice is that age here, this column, has been sorted. So starting with the lowest, it's in ascending order. Try it for any of the other columns too, vote or education. You could arrange by anyone. So that's ascending, but you might also want to know descending, which I actually don't include in the note here. Sorry, I will change that. But descending is the same exact function, but inside the arrange function, you put DESC, so that's descending, and then age, or whatever it is that you want to see. And then run it, and you'll see that it's now been sorted. Now again, if you wanted to save this data frame, you could type in a new name followed by the equal sign, and then you always want to get rid of the head when saving a new data frame, because we don't want to just save the first 5 rows, we want to save all the rows, and then you'll notice that we have a new data frame there. Now I want to get on to the mutate function, and the mutate function allows us to create a new column. The first example that I'm showing here is actually a little bit complicated, so let's make it a little less complicated. So we type in the name of our data frame, followed by the pipe operator, followed by mutate, and inside we put the first thing we type is the new name of our column. So this can be anything. So your name, you can put it, you can make it up. So let's just do income plus 10 equals the income variable, or the income column, plus 10. And let's actually put the head function on there just to make it a little bit easier to read. And what you'll notice down here is this new column is just this income, each observation, adding 10. Okay? If you were to not add anything, it would just be the exact same column. But you can also, as I show in this example, add a function. So this function is log, and so that will just take the log of the income variable. Now I think you might notice a theme. If we wanted to save it, what would we do? Take a moment to think about that. Well, first we'd want to get rid of the head function, and then we would type in a new name equals to, and then we would have a new data. If you wanted to, though, overwrite the data, what you would do is type in the name equal to the original name. So these two names are the same, and then run the whole thing. And what you notice is our original data frame has now been edited. But as I've mentioned many times now in this video by now, I don't prefer to do that because I like to hold on to that original data set to refer back to it. So you can also do that with, you can also, as in I show in 4.2, you can create more than one new column at a time by just adding an apostrophe or a comma, excuse me, and then the new name of the column. So this example just shows me creating 2 new columns. So now I want to just cover the very last 2 functions that we're going to be using a lot more in the coming videos, summarize and group by. So summarize is relatively easy, I think, to understand. It's the name of our data frame followed by the summarize function, and then let's just show you one example at a time. I want to take the mean of education, so I can just type in mean education, or whatever it is that I want to type here, equals to, I think you know this theme by now, and then you type in the mean function, and then within that education, and what you will see if you run that is just the mean of education. But this is nice function. This is a nice function to use because you can add multiple summary statistics, mean, median. There's a bunch of different ones that I think we can cover in later videos, and you can run those at the same time. So you can actually get it for both age, education, whatever it is that you want to see. And the summarize function group goes really well with the group by function because it will allow you to see the summary statistics, but broken up by a certain categorical variable. And in this instance, the categorical variable, well, technically it's not categorical, but it's kind of close. It's a dummy variable of whether people voted or not. So dummy variables take the 0 or 1, 1 being like a positive instance of that, and 0 being a not positive instance. So in this example, a 0 will be people who did not vote, and a 1 will be people who have voted. And in your assignment, you're probably going to see gender being 0 or 1, where female, for example, would be 0 and male would be 1, or vice versa. And so we would group by that vote column, and then we would take the mean income, and again, this is just the name we give it, as we did in summarize up here, equals to the mean of income. And let's actually just run that again. What you'll notice is that there's a vote 0 and a vote 1 and a different income for each. So for the people who did not vote, they have an income of 10.9. The people who voted, they have an income of 12.3. You could also use education. It would be a few more categories, but you can see that for each education level, there is a different mean income. So that is all I wanted to cover today. Hopefully this was beneficial, and hopefully you understood that when we can use external libraries, we can access a lot more functions, and we just have to be careful about how we install those libraries. Anyways, see you next week.